Hello. Today I want to talk about a new device that we have developed called HydraSENS. But because it is so related to HydraCheck, I will explain HydraCheck as well. But HydraSENS is for early detection of sign of hydrate formation. So we can detect early sign of hydrate formation and its potential location. Where is forming? Middle of the pipeline, in the beginning of the pipeline, towards end of pipeline, because it will help us to find a solution. If it is, for example, it is in the beginning of the pipeline, we need to inject inhibitor from beginning of the pipeline. If it is end of the pipeline, so maybe we decide to reduce the pressure. So first, hydrate management. Gas hydrate form at low temperature and high pressure. And it is a major problem in flow assurance. Mitigation, different technique, chemicals, methanol, ethanol, glycol, low dosage hydrate inhibitor, but we can also control with amount of the composition of gas phase and aqueous phase. So in the aqueous phase, when hydrates form, a structure will form like this. This is you see that this is water, this is gas molecule. And this is the hydrate phase boundary. So to the left of this phase boundary, we have hydrate. To the right, we don't have any hydrate. These phase boundary depend on the composition of gas phase and aqueous phase. The more ideal size of gas molecule, they can be closer to each other and much easier to form hydrate. And if there is some component in the aqueous phase, they can control hydrate formation. And when hydrates form, we can also see that hydrate formation. See here, you can see that this gas phase. This is aqueous phase, and hydrates form at the interface between gas molecule and aqueous phase. And you see that a lot of gas is trapped in the hydrate, and that prevent further water being converted to hydrate. So the key point is that to keep the pipeline condition outside hydrate phase boundary, or to certain amount inside. That's a different issue. But in general, this is hydrate phase boundary. This is the pipeline condition. So hydrate stability zone depends on the hydrocarbon phase that normally doesn't change, and composition of aqueous phase that has depend on the salt and chemical hydrate inhibitor. The other point that control hydrate safety margin is pipeline condition. And by computer modeling or having meter, temperature meter, pressure meter, or pipeline, basically the depth of the water temperature. It is a major problem that can cause problem, and we need to have a system that can detect if we are going to form hydrate. Normally, we take sample of the produced water and send it to the lab, but normally we get the result up to 12 or 24 hours, which is, it is too late in a way. We developed a technique, device and technique that measure basically electrical conductivity, speed of sound, temperature, and pressure. Two parameters measured there, therefore we can detect two material dissolved in the aqueous phase. Normally, one material salt, the other one chemical hydrate inhibitor. But you can have three parameters as well by measuring the change in the velocity of the sound versus temperature. So then we can detect three parameters. For example, we can detect one salt made with another salt, or with KHI, or methanol. So, but normally we use two unknowns. So once we know hydrocarbon composition, which doesn't change a lot with time, and measure the amount of MEG and salt, combination of the two, we can plot hydrate phase boundary, and this is the hydrate phase boundary, and then superimpose with the pipeline condition. We can see that if the condition is here, then there is a risk of hydrate, so we put here hydrate risk. Here, the amber line, there is risk much lower, but we don't have a lot of safety margin. And here, green is ideal, but here we are injecting too much inhibitor. So obviously we are causing a lot of costs and also damaging the environment. If we don't have any water phase, we have technique without any water phase detect hydrate stability zone. Now, I want to talk about detecting early sign of hydrate formation. So we were trying to avoid hydrate formation, but for whatever reason, we can be wrong, okay? So we want to see that if we can develop a technique to detect early sign of hydrate formation. Now, different component, this is H2S, this is iso4, this is C3, this is ethane, this is CO2, this is methane, this is nitrogen. So you see that different components have different affinity to form hydrate. In fact, what happened, the attraction between two molecules depend on the distance between the two molecules. If they are far away from each other, they don't have a lot of attraction and repulsion. As they get closer to each other, they have attraction. and this is maximum attraction here, and then they repel each other. And from there, we can see that how much a compound can promote hydrate formation. And this is the curve created here. So the key point I want to say to you is that when hydrates form, the composition of hydrate phase is different from the gas phase. In fact, the hydrate phase, which will remain in the aqueous phase, have a lot more, for structure 2, for example, a lot more C3 and IC4. And therefore, the gas phase would have less of this component. So in a pipeline, we can have 3 phases. So gas phase, liquid hydrocarbon, aqueous phase, or 2 phases, gas and aqueous phase. When hydrates form, heavy component with respect to hydrate formation, we go to the hydrate phase. There will be some changes in the liquid hydrocarbon phase, but the gas phase lose a lot of intermediate gases. If you have 2 phases, gas and aqueous phase, again the same thing will happen. We can detect the changes in aqueous phase and gas phase. Normally, gas is the fastest moving component, so we see the changes in the gas phase much sooner than gas aqueous phase. And this is the device